having defined complex functions, there's no natural question, can we also differentiate or integrate them? And the answer for this course is that as long as we differentiate or integrate only over real variables, such as entering in the real or imaginary part of the complex number, then all the usual rules apply and there's not much extra actually. So there is the whole theory about integration over the complex plane, which is very interesting, but it is beyond the scope of this course. Because all the usual rules apply, this video will actually be very short. I will only show you two examples. And the first one is an example of differentiation. So I want to calculate dd phi of e to the I phi, so of the complex exponential function. Now, when I differentiate, now I know the usual rules apply. So if I differentiate the exponential function, I get the exponential function again. So I get e to the I phi. But now I also need to differentiate the argument of the exponential function. So I need to apply the chain rule. So this is d phi I phi. And there we see that this is very simple. This just gives us an I. So the total result is I times e to the I phi. So you see actually the complex number just behaves here such as if the I was just a variable. It's the same actually. The same holds for integration. So here I'm integrating now over e to the I phi from 0 to pi. If I do that, I need to find the antiderivative of the complex exponential function. And that is, as we can clearly see from the previous result, 1 over I times e to the I phi. And I need to plug in for the boundaries 0 and pi. And when we do that, then 1 over I is actually the same as minus I. And e to the I phi, that's minus 1, minus e to the I0, that is 1. So that we see that this bracket here is minus 2. In total, we get 2i. So these were two simple examples where you see that actually differentiation and integration for a complex function is very simple. In the exercises, you will find more opportunity to train that.